Welcome to my next video on coordinate geometry. I said that in our next video we are going to talk about the distance between 2 points. But before we talk about the distance between 2 points, it is important for us to go back and go through the Pythagoras theorem. This is a very famous theorem which we normally come across when we are in high school. It states that if we have two sides known for a right angle triangle, we can find the other side by using these two sides. Okay, what does it say? It says c squared, which is the hypotenuse, is equal to a squared plus b squared. So the longest side, you square it, it is the same as the two shorter sides. Okay, you add them together, each squared. Okay, so what is the key point? This triangle has to be a right angled triangle. Okay, for this theorem to hold, for this theorem to work, it only works when the triangle is a right angled triangle, meaning it has a 90 degrees somewhere. Okay, so this is the longest side, the hypotenuse. Okay, and then we have the opposite side and the adjacent. Okay, so the hypotenuse squared is equal to sum of the adjacent squared plus the opposite squared. Okay, so this is the Pythagoras theorem, and we can see one example. Like we have a right angled triangle here. This is a simple one. Okay, we have the opposite side is 1, then the hypotenuse is 2, so we can find this side which is unknown, and we call this side x. Okay, so c squared is equal to a squared plus b squared. Okay, so we square 2, okay, and then we square x and we square 1. All right, we square both the sides. So 2 squared, we know it's 4, and then squaring x we get x squared, squaring 1 we get 1. Then we go ahead, x squared, then we collect the like terms, the numerical terms, we put them the other side, which is 4 minus 1. So we have x squared is equal to 3. Then we get the square root from both sides, and x is equal to the root of 3. Okay, we cannot simplify any further unless we are using a calculator. Then we can now see another example, which is a very famous example. We have the hypotenuse 5 units, then we have the opposite 3 units. We know that this side will be 4 units. Okay, when we say c squared is equal to a squared plus b squared, so when we square 5, okay, and we square a and we square 3, we collect the like terms. Okay, so when we square 5 we get 25. So 25 minus 9, which is as a result of 3 squared, so 25 minus 9 is equal to a squared, and the square root of this difference is the value of a. Okay, so what is 25 minus 9? It is 16. Okay, and the square root of 16 is 4, so we get this side, it is equal to 4. All right, so now we get the idea of what this Pythagoras theorem works. We revise it. Okay, this is not something new to us. We know how it works. We were just getting to remember it. Okay, so that we can apply the same concept when dealing with the distance between 2 points in a Cartesian plane or in a coordinate plane. Okay, yes, so now we can go ahead and talk about the distance between 2 points. Okay, so now what we talked about in the other video, locating points. Okay, we know how to locate the points. First of all, we move from the origin until we find the point. Okay, so this is x1. It represents the x value. Okay, we don't know, so this is just an arbitrary value. Okay, so x1. All right, and then we draw a straight line to to where y is, okay, and this value is y1. So where these two lines intersect, that's where the point is, okay, the point P x1, y1 as our first point, okay. Then our second point also is Q. Q is x2, y2. We can locate these 2 points, okay. We know how to locate them. Now we can join a straight line, starting from this point to the other point. We draw a line to join the points, okay. Now we see that when we draw a straight line down to x2, okay, and also we draw another line down to x1, and then we draw this horizontal line in between this line, we will see that we are forming something like a right-angled triangle. We can see clearly that this is a right-angled triangle, okay. So we have two points here of x2 and x1. Then we have 2 points of y here, y2 and y1, okay. So this is a right-angled triangle. And how can we find the distance of this line, okay? We can find this distance if we know the distance of this line and also this line. By what? By Pythagoras theorem, because this is a right-angled triangle. We can find this distance by squaring this side, this distance and this distance. So now we know that d squared is equal to this side squared plus this side squared, because we have performed Pythagoras theorem on this triangle, okay. So this is what it is actually. D squared is equal to PQ squared is equal to x2 minus x1 brackets squared plus y2 minus y1 brackets squared, okay. Now since this distance is squared, how would we find the actual distance? It is by taking the square root from both sides, okay. The square root of d squared is d itself, okay, and the square root of pq is pq itself. Then the square root of this side is x2 minus x1 squared plus y2 minus y1 squared under the square root, okay. So this is the general formula of the distance between 2 points. We will see this formula quite often, okay. So now we can perform some examples just to see how this formula works. So we have 3 examples, A, B and C, okay. Our first example is 2,4 and negative 6, -6. Then B 3,8 and 4, negative 4,8, okay. And C is 0, 0 and 2,2, okay. For the first example, I plotted it on the Cartesian coordinate just to show that actually these points are mapped on the Cartesian plane, okay. So we join the line, okay, between these 2 points, and we form a right-angled triangle. We can easily see that, okay. Now we know that the distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, okay. We just need to put the values in this formula. So it doesn't matter which one you pick to be x1 and y1, okay. You have to pick one side, okay, but the result won't change because the distance is always the same, okay. So what we are saying is we can either choose this side or this side to start with. So here we have x2 as 2 and x1 as -6, okay, and we have y2 as 4 and y1 as -6, okay. When we perform this operation, of course we know negative gives us positive, okay. When we perform this operation, we get the square root of the square root of 164 units. We can simplify further, but that will need something like a calculator, or we can simplify it by hand, but we'll spend some time. So now let's do B. Okay, for B we are using the same formula. Okay, now we decided that our x2 is 3 and our x1 is -4. Okay, negative is positive, so we have 3 plus 4 here, squared, that's 7 squared, that's 49. Of course, 8 minus 8 is 0. Okay, that has no effect. So we have the square root of 49, which gives us 7 units. We are saying that these are units because we are going to have something like centimeters, because this is a distance. We're going to have something like meters, kilometers, miles, but we don't know what it is, so we use the general term. These are units. Okay, so for C we have 0,0 and 2,2. Okay, we're using the same formula. We just need to add these values in the formula. So we choose x2 to be 2 and x1 to be 0. Okay, and we choose y2 to be 2. Okay, and y1 to be 0. Okay, performing that, we have 4 plus 4, and this is square root of 8, which is 4 times 2. Okay, the square root of 4 is 2. Okay, that is 2 square root of 2, 2 root 2 units. All right, so yeah, you know what I'm saying is it doesn't matter which pair you choose. Okay, if you want, you can say that x2 is 0. All right, 0, it will be 0 minus 2, which will be -2. -2 squared will be 4. Okay, now another thing will be 0 minus 2 will be -2. -2 squared will be 4. Be 4 plus 4. The answer is the same. Okay, yeah. All right, that's all that we had for today, and I hope I have explained. This is what I can, but if you have any question or contribution, you can add. Okay, you can add. You can always ask a question, or you can contribute. Okay, you can teach where it is inadequate. Okay, thank you, and see you in the next video. Okay.